Hello everyone, welcome back to your channel The Ghadi Insan. So in today's video we'll be continuing with the evolution of neural network. We had seen till like LSTM, right? Yeah, it could remember long contexts via the gates, right? Three gates that we had seen, right? Input gate, output gate, input gate, forget gate, and output gate, right? Kind of remembering the relevant information in short. If you want in detail, you can go to the previous video. Kind of remembering what is relevant, not one, all. Okay. But what is the problem with it? The problem was sequentially reading the word, that is one by one. When large documents or long paragraphs came, training started becoming complex and time taking. Okay, so this was the issue, right? For large documents or paragraphs, training started becoming complex and time taking. Thereby, it was not able to give good translation results for longer paragraphs, right? You remember the example that we were discussing? Please refer the previous video, please. uh, there is a context of the previous video, right? We are talking about the context, so there is a context, you need to go through that video. So the example was, we were discussing a problem. I go to market, English needs to be converted to Hindi, that is मैं बाजार जाता हूँ, right? In getting, so this was the problem, right? Sequentially reading. So there came transformer. It introduced very important term, self attention mechanism. It could process the entire sentence at once. Suppose the sentence, I go to market to buy vegetables and fruits. So all the words can be seen at once, and the relation between all the words can be established even though how far they may. Let me make it clear. That is vegetable, that is fruits, and I also relation can be built. Because of this self-attention mechanism and because of this parallelism, so translation started becoming accurate for even longer words, longer, or what to say, big sentences. Getting what is the self-attention? There may be multiple words, right? Multiple words in a sentence, right? So as I told, as we know, this transformer builds relationship of each word with the other word, and thereby it can refer or understand how much important or dependent the current word is on the previous word. Let me tell you example. Uh, there is a boy named Dubey. Okay. Eh, okay. This one another sentence. He loves dancing. Let's. Okay. Now he can be directly understood as we are able to understand, right? When I talk about he, I am talking about Ankit Dubey. This same thing, this same thing became possible in transformer, right? That when I talk about he, I talk about Dubey. So this is the self-attention mechanism. Okay, building the relation of each word with the other, and which is the most relevant is kept up more priority, and accordingly translation happen. This transformer architecture is accepted or used in Google Translation translator. Okay, so you can understand like what level of thing is this. The Google Translator is using this architecture. Getting now. So this is the all the good things with the transformer. But if you remember when I was discussing about the foundation model, I was told like it is a general purpose model that is, it can perform variety of tasks. This was what was lacking in transformer. So this is what it could solve, right? Benefits, right? Benefits or benefits that and then came problem problems with the transformer. So it couldn't solve general purpose tasks, that is variety of tasks. It could only do kind of translation. Okay. But this became very important. From there only the revolution happened. All this generative AI, all these LLMs, all these agent are totally based on this architecture. Transformer, LLM, the models, the ChatGPT that we are using are all been scaled transformer architecture. So LLM, what it did? Scale transformer architecture. Transformer architecture. It came as a general purpose model. Full form of LLM, let's type it down. Large language models. Getting. See, what problem? I'm giving you the example also like what it will solve. Suppose you told I go to market. This transformer converted it very goodly. बहुत अच्छे से it converted. Okay. मैं बाजार जाता हूँ. Now if you ask a question, you ask a question. Okay, what is the best time to go to market? It won't be able to answer. It won't be able to answer. Getting. So to solve this, LLM came. Okay, it kind of scale transformer architecture. It came as a general purpose model through which we can code, we can do question and answer, we can do reasoning, right? Just think as a chat GPT. This is totally chat GPT. Okay, initial chat, right? So it provides us code, it provides answer, question and answer, it can do reasoning, right? So this is what we'll be building this LLMs. Okay, we'll be fine tuning the available models according to our task and make generative AI applications. Okay, we'll be seeing that very soon. That's going to be start probably next video. So tomorrow we'll be discussing about that Amazon Bedrock, how to set it up, and the next video just start with the coding. Okay, so chat GPT. But one problem. What is the problem with LLM? This was all the benefit it could, right? Was all the benefit it got. What it's all like. Okay, and problem with LLM is, yeah, can generate, but can't perform real time tasks like accessing your files system in computer, browsing web pages, getting by itself like if I expect that generative AI or ChatGPT or that application LLM to itself go to some browser and do some browsing and give some results, right? Browsing web pages and tool external tools, use some external tools, not able to use external getting like accessing your file system in computer, right? All these things can't do things like can't do like accessing your file system in computer, browsing web pages, not able to use some external tools. To solve this, to solve this, agents came. Solve this came. Suppose what I'm telling you the problem, like yeah, it converted your English to Hindi. This one, your question what is the best time? This one, yeah, I could convert like this thing. Okay, let's copy it down here. Yeah, could do. It will be also able to answer. If you ask a question, what is the best time to answer? It will be able to answer. It will be able to answer. But if you say, okay, then create a alarm in my system for half an hour before, half an hour before that time, it won't be able to do. Won't be able to do. So agents are what? Agents are LLM plus tools plus planning. That we speak. Another drawback with the LLM. Okay. You think I told you like yeah, this can't access your file system, browsing web pages. When when you give multi-steps tasks, you won't be able to perform because not able to plan. So what this LLM started doing, this agent could do planning, it could maintain states for multiple tasks and thereby perform real-time operations also. Like example, I am giving you Claude code. Claude code can access your file system, generate a new file. I know all the guys who have been explored cloud code, all are aware of this, right? Generate a new file, write code in that, right? You give a problem statement, some statement, okay. Uh, it will create some steps, maintain steps for that, states for that, for those steps, and accordingly perform real-time operation, right? Right, we all have seen through this cloud code, right? It's able to write the code, it's directly able to go to the file system, create pages, write code, it's able to browse with pages, able to do API, external API calling. So you would be thinking, oh my god, this is very great. It's able to access file system, it is able to write the code, it is able to browse the web pages, I don't need to search anything, just I will give a prompt to the cloud and it will do everything. External API calling and all, it will integrate everything. No, nothing issues, right? Very good. So, like you tell like GitHub, you give your GitHub secret. No, the problem. See, you are suppose I'm telling you the problem. Now the comes. That's why the human role is very still relevant. You suppose you, how mistake I do now. You suppose work in a company for some client. Okay. To access that project, there are access keys and create keys. Now, for doing, yeah, we have access to Claude for your uh, project database and code and all getting. So it perform tasks for you. But see the risk. Now the Claude has got access to your client's database. It can add something for you, can delete as well. What if it leaks the secret key? So you can understand what is going to happen, right? So over reliability on this cloud on all is not good. First of all, this ring 6 can happen, learning can be lost, proper architecture or architect that you wanted to become in future, that you can't become by doing that. Right. It's true for all, for me also. So that's all right. So the problem is what? Problem we have agent is error prone on label. So still work is going on this. Okay, people are trying to make it label. Okay, so that's all for today. In the next video, I will be giving a walkthrough of AWS account creation, like something simple steps. You can do ChatGPT also, but I will give a short view of this, and then on bedrock surveys, right? And after that, we are good to start with building the chatbot. Okay, what is the chatbot we're gonna to build? Uh, that I will be kind of creating another video. Okay, that I will describe like what we're gonna do. What these two videos will come, and this now then after this that coding will follow step by step. That stages, right? If you remember all these stages. Now, if you see here, we are at this right till here. We are been able to come. As I told, I will update the state. See, I added many things new, right? Like evolution neural network part one. I had that time not planned, but added now, right? So let me update this also, like understanding coordination model, the evolution of networks, right? Okay. To RNN to ST to transformer to here also we had introduced NLP, talked about NLP techniques, right? Word embedding techniques, right? And we'll be going through all these stages one by one, and we'll be reaching till here. Okay, so that's all for today. Keep coding, keep exploring. Cadenza. So, hey, wait. Please, when you watch the video, you can type kind of a comment, right? Like what you understand in the video, right? That you can do, right? That's all. Thank you. Cadenza.